All right, welcome to today's Explainer, where we're digging into something truly mind-bending, biological blueprints. When we think about advanced engineering, our minds instantly go to massive steel skyscrapers, roaring rockets, or those incredibly intricate microscopic silicon chips. We naturally default to human achievements, right? But here's the crazy thing. The absolute most sophisticated, high-tech engineering on the entire planet, it's not happening in some pristine billion-dollar laboratory or a top-secret government facility. It is happening right outside in nature. And honestly, it is vastly outpacing our current human capabilities. Okay, let's dive right into this, because you've got to hear some of these logic-defying survival traits. We've got animals literally surviving being completely frozen solid in the dead of winter. We have organisms that can enter these wild states of suspended animation, going without a single drop of water for years at a time, decades even. Actually, scratch that, the source just safely says years, but it's still absolutely unbelievable. And we even have creatures like the axolotl just casually regenerating entire, fully functioning limbs after losing them. We're talking complete with intricate bone structures and complex nerve networks. It's wild. And these aren't magic tricks. These are tangible biological feats happening on Earth right now. They completely challenge our baseline understanding of biology and defy everything we intuitively think we know about the fragility of life and the absolute limits of cellular endurance. Okay, let's take a collective breath and just slow down for a second. To really wrap our heads around how this is even possible, we need to look past that initial shock value of these superpowered traits. These organisms operate so incredibly far beyond the standard parameters of basic survival that they actually fall into a completely different category altogether. So, welcome to the fascinating world of what we classify as Type 4 biological entities. This is the exact point where we have to shift our perspective. We have to stop viewing these animals as just, quirky biological curiosities and start analyzing them as highly advanced living machines. We're treating them not just as fauna, but as complex, naturally engineered systems that have optimized their internal operations over millions of years to achieve what is basically a state of mechanical perfection. To ground all this in the actual science, we are talking about extremophile biology. These are organisms that don't just endure, they completely thrive in conditions that should be downright impossible. Think about environments like crushing deep-sea hydrothermal vents or freezing subglacial lakes, conditions that would instantly obliterate standard cellular structures. By categorizing these specific extremophiles as Type 4 biological entities, we're acknowledging a massive paradigm shift. Their internal biological systems are functioning on a radically different, highly elevated tier of mechanical survival compared to your average organism. They process extreme external stressors with a level of efficiency that literally mirrors the most advanced structural and chemical engineering we humans can even conceptualize. It is extreme biological engineering at its absolute finest. Now, what's really interesting about this whole biological pivot is how we can narrow our focus. We can zoom in from that massive, broad concept of extremophiles right down to one incredibly specific, awe-inspiring mechanism. We are going to do a deep dive into the wood frog. This tiny, seemingly ordinary amphibian holds a biological secret that practically hacks the physics of freezing temperatures just to survive. Let's walk through the chronological physics of exactly how this little creature pulls this off. The first step is simple. The environment experiences an extreme temperature drop. It gets dangerously, lethally cold out there. Then, the unthinkable happens. The frog's blood completely freezes solid. Its heart literally stops beating. Its breathing ceases entirely. Now, normally, for any living creature, this is an absolute point-blank death sentence. Think about it. When water freezes, it expands, right? It forms these jagged, razor-sharp ice crystals. Inside a living body, those ice crystals act like microscopic blades, completely shredding the fragile lipid bilayers of the cells from the inside out. But then comes the real magic and the final step. The wood frog executes a flawless defensive protocol. It floods its entire system with natural cryoprotectants, primarily these massive surging spikes of glucose and urea. It's essentially acting as a biological antifreeze. This completely prevents those ice crystals from shredding its cells. It draws the water out of the cells, so the freezing only ever happens in the extracellular spaces. It safely freezes its blood while keeping its delicate internal cellular architecture perfectly intact. This is a sheer mechanical impossibility for almost every other life form on Earth. Yet this frog executes it flawlessly, every single winter. And this brilliantly illustrates a profound connection between biology and structural engineering. Consider the biological physics of the wood frog we just explored. You've got its internal defense mechanism actively managing pressures and physically blocking those jagged ice crystals from penetrating and destroying its cells. Now compare that to the pinnacle of human engineering, something like the Cheyenne Mountain Complex. This is a massive, highly fortified military bunker that utilizes highly specialized, multi-layered air filters and blast valves, and they're designed specifically to block dangerous external particles and pressure waves from penetrating the secure facility. The crazy thing is, the frog is utilizing a microscopic cellular version of that exact same structural engineering concept. It is precisely managing external threats and selectively filtering exactly what is allowed to interact with its vital core. It is literal structural engineering happening at a cellular level, and it's doing it entirely instinctively. This brings us to the absolute core realization of this entire explainer. When we put these two things side by side, the conclusion is absolutely undeniable. Nature has already engineered incredibly elegant, hyper-efficient solutions to massively complex mechanical and physical problems. Our human Type 1 technology, which is basically characterized by heavy machinery, massive energy consumption, and, let's be honest, brute force engineering, is still desperately struggling to catch up to the sheer elegance of biological adaptation. We are literally still trying to figure out how to replicate in a modern, climate-controlled laboratory what a tiny frog does effortlessly in a frozen forest without consuming a single drop of external power. Nature really is the ultimate architect. It's utilizing millions of years of research and development to build flawless, self-sustaining systems. So I want to leave you with a lingering thought to really chew on as we wrap up today's explainer of this incredible source material. If a tiny amphibian has already mastered the biological equivalent of military-grade structural defenses and complex cryogenics just to survive a cold winter, what other massive engineering problems has our technology been desperately struggling with that nature has actually already solved? The blueprints are out there. They're hiding in plain sight, just waiting for us to finally understand them and translate them into our own designs. Think about it. Thanks for joining me on this deep dive.